For the previous problems, when we were integrating, we were able to find the slope, but we weren't necessarily able to find the whole equation because we didn't know any starting points. Basically, it's like we had a slope without an xy point, so all we could tell you is the general form of what things look like. What we're doing now in problem 4 is we're adding an initial condition. The initial condition, like f of 0 equals 3 or f of 1 equals negative 2, acts like a point on the line, where basically we can solve for the plus b to get the full equation instead of having to put plus c in everything. So the way I need to read this is, since the derivative is 20x, I'm going to be integrating 20x dx. When I do that, the 20 stays. This x, I add 1 to the exponent. It used to be 1, it now becomes 2. And I divide by the new exponent, plus c. What that tells me when I reduce 20 and 2 is that I get 10x squared plus c as my final answer. That's my answer for f of x. But then we're given another piece of information. F of 0 equals 3. What that means is, if I plug in 0 everywhere where I see an x, I should get an answer for y that is 3. So if I do 10 times 0 squared plus c, I should get an answer of 3. 10 times 0 squared is just 0, so the equation reduces to c equals 3. Now that I know what c is, I can write the full equation. F of x equals 10x squared. Instead of writing plus c, I can write plus 3. Applying the same principles to the second problem here, part b, I'm taking the integral of 15x squared minus 5x to the 4th dx. When I integrate the 15x squared, it becomes 15x to the 2 plus 1 power, which is 3rd, divided by the new power, minus 5x to the 4 plus 1 power, which is 5th, divided by the new power, plus c. Cleaning it up a little, 15 divided by 3 is 5, x cubed. 5 divided by 5 is 1, so minus x to the 5th, plus c. We're now given the initial condition that when I plug in a 1 for x, I should get a negative 2 for y. So since this equals f of x or y, I'm going to plug in that negative 2 where I see it. Everywhere where I see an x, I'm going to plug in a 1. And that's going to allow me to solve for the only unknown, c. 1 cubed is 1, so this resolves to 5. 1 to the 5th is also 1, so minus 1 plus c equals negative 2. 5 minus 1 is 4, so 4 plus c equals negative 2. Subtract 4 from both sides, and that's how I get c equals negative 6. Once you've solved for c, plug it into this version to find the singular f of x, which both fits having this derivative and fits having this initial condition. So my final answer is 5x to the 3rd minus x to the 5th minus 6.